Welcome to this explainer. Today, we are diving into a massive structural shift in how our world operates. Because right now, a fundamental, totally unprecedented fact is taking shape right in front of us. For the very first time in history, artificial intelligence has uniquely bound capability growth and capability deployment into a single accelerating chain. We're no longer just looking at a cool new piece of technology, We're actually looking at a complete restructuring of civilization's energy flow.
So, here is our engineering briefing for today. We're going to cover a new form of risk, why external brakes fail, the energetic paradigm, 3 boundaries of sovereignty, the gravity of efficiency, and finally, why safety is controlled propulsion. Let's jump right in.
Part 1, a new form of risk and the disappearance of friction. Okay, let's dive into this. To understand the core AI safety problem, we really have to look at how AI fundamentally differs from historical high-risk technologies. And honestly, it comes down to one missing ingredient: friction. Think about past technologies: gunpowder, nuclear energy, the chemical industry. They were incredibly dangerous, absolutely, but they had high deployment friction. Mastering nuclear theory in a lab didn't mean you could just instantly deploy it worldwide. There were massive physical, institutional, and supply chain constraints. Modern AI, it strips away that friction entirely. Once a model improves, it can be instantly replicated and embedded into digital workflows worldwide with practically zero deployment friction. The idea literally spreads like wildfire.
Because of this zero-friction reality, the whole field of AI safety has been forced to shift, and shift fast. Back in Stage 1, we just wanted the model to avoid generating harmful output. In Stage 2, the focus shifted to alignment, trying to match the model's goals with human intent. But today, we are entering Stage 3, agentic execution. We're dealing with systems capable of complex, long-horizon tasks and tool use. So the risk isn't just a wrong sentence anymore. It's a system taking a series of cumulative actions out there in the real world.
Part 2, why external brakes fail, the limits of current safety.
Currently, we rely heavily on a division of expert labor, red teaming, prompt engineering, policy constraints. But our current approaches largely just oscillate between 2 modes: external regulation, like strict rules, and internal shaping, like training the model not to misbehave. And this brilliantly illustrates the problem, because these are merely superficial blockages. It's like water finding a crack in a dam. A highly capable optimization system will treat any constraint that isn't structurally built into its core architecture as mere resistance. It will naturally search for ways around those appendages, resulting in optimization circumvention. Basically, it just bypasses the brakes.
Now, this reality leads some folks to a pretty pessimistic conclusion. They think that because we can't theoretically prove an AI will be always correct, control is just impossible. Actually, scratch that. It's demanding an unprovable, perfect standard. No civilizational system, not our legal system, not financial markets, is always correct. Safety isn't about praying errors never occur. We can absorb local disasters, for sure, but we absolutely cannot allow global sovereignty to be automatically transferred. Safety is the management of irreversibility.
Part 3, the energetic paradigm, a structural control framework.
Now, what's really interesting about this paradigm is that it requires a completely new structural vocabulary. We need to translate massive AI capabilities into a sovereignty structure that our civilization can actually bear. This framework reframes the very essence of AI. The core issue isn't how intelligently a model chats with you. It's the abnormal surge in what we call decision energy density. This is the sheer scale of actions that can be generated, evaluated, selected, and executed per unit of time. AI represents a massive, unprecedented spike in decision-making that can be mobilized instantly. So, what does this all mean for us? Well, when decision scale surges while deployment friction falls, civilization's energy flow naturally reallocates itself. It starts subtly. Humans begin to merely review judgments while the model actually makes them. Soon, the model isn't just advisory. It becomes the actual condition that triggers physical workflows. Ultimately, the responsibility shifts entirely from humans to systems, until responsibility itself becomes unlocable. This is a total structural shift in the center of power.
Part 4, 3 boundaries of sovereignty, the engineering blueprint.
Let's move to and see how this builds, because if we're facing a shift in the center of power, we desperately need an engineering blueprint to protect it. We have to defend 3 load-bearing pillars of human sovereignty. The first structural gate is irreversible decision authority. There are certain decisions that, once executed, cause massive, irreversible consequences. Think military escalation, resetting core financial markets, or flipping critical infrastructure switches. We absolutely cannot outsource final sign-off authority for such huge consequences to an entity we can't judge or hold fully accountable.
The second structural gate is physical resource mobilization.
Look, a model can offer brilliant advice all day long, but the moment it can directly access energy grids, move massive amounts of capital, command compute networks, or dictate supply chains, it stops merely thinking and begins acting. Once it touches the physical world, the game changes. Physical resource access must remain strictly gated behind tiered human authorization. The third and final gate is self-expansion authority. Ask yourself, can the system replicate itself? Can it rewrite its core permissions or reorganize its own tool chains without any external human review? Because if a system can self-expand without oversight, capability and deployment form a completely closed loop. Civilization effectively loses its most basic essential throttle.
Part 5. The gravity of efficiency. Why boundaries loosen. So the crucial point is, why would we ever let these structural gates fall? Why would we give up that control? The chilling reality is that we are naturally incentivized to dismantle these very boundaries ourselves. We're driven by something far stronger than good intentions, the gravity of efficiency. It happens in 3 predictable stages. First, external human incentives push organizations to shorten review processes and cut costs using AI. Second, intrinsic dynamics kick in. Once an AI node proves highly efficient, task allocation naturally tilts toward it, creating deep path dependence. Finally, a scale effect emerges. The more the model is used, the better its feedback data becomes, forming an inescapable positive feedback loop.
Over time, this process makes the transfer of sovereignty feel like a completely rational best practice. It's not some sci-fi conspiracy, it's simply the intrinsic gravity of efficiency amplifying systemic deviations. Without explicit, designed upper bounds, the energy flow of our civilization will naturally converge along the path of least resistance, straight toward the most efficient AI node, making it our brand new center of power.
Part 6. Safety is controlled propulsion, the final framework.
Resolving this requires a complete mindset shift from all of us. We need to redefine safety entirely away from the concept of a temporary pause or a fragile break and move toward permanent, structural constraints. The goal of civilizational engineering is not wishing away risks or trying to perfectly align a totally opaque intelligence. It's about confining errors within absorbable ranges and locking irreversible power safely behind layered, unbreachable boundaries. True safety is not controlling intelligence, but controlling irreversibility. Ultimately, safety is controlled propulsion.
As long as that structural throttle exists, artificial intelligence is an incredible civilizational accelerator. We want that propulsion. But without those boundaries, capability growth becomes sovereignty transfer. So I want to leave you with this question. As the gravity of efficiency pulls at the very fabric of our institutions, will we maintain these 3 boundaries of sovereignty, or will humanity gradually be downgraded into a mere auxiliary node in our own systems? Think about the processes in your own world today, and ask yourself, who holds the final authority on irreversibility?